Hey everyone, welcome back, and today let's solve Leetcode problem 150 titled Evaluate Reverse Polish Notation. So we're given an array of strings tokens that represent an arithmetic expression in reverse Polish notation. We have to evaluate the expression and return an integer that represents the value of the expression. And the way we actually solve or evaluate the value of the expression is the valid operators are going to be the plus, minus, multiplication, and division operators, all inputted as strings, and each operand may be an integer or another expression. The division between two integers always truncates toward 0, or in other words, we're always going to round towards 0, and there will not be any division by 0. The input represents a valid arithmetic expression in a reverse Polish notation, and the answer and all the intermediate calculations can be represented in a 32-bit integer. So honestly, these last three lines of constraints simply tell us that we don't actually have to handle any weird edge or base cases where our data could potentially overflow, our input could overflow out of a 32-bit integer, or we have to divide by 0. We're not going to face any of those weird edge cases, and so we don't have to worry about that, which makes this problem a million times simpler. So in example 1, we have the input string tokens array to be 2, 1, plus 3, and multiply, or multiply operator. And so first, we'd add, using this add operator, the most recent elements to be 1 and 2 in that current iteration or traversal of this input string tokens, which would yield 2 plus 1 because we have the plus operator, which is 3. Then we see this multiplication operator, which tells us that we have to multiply our current result by the most recent element, which is going to be 3 in this case. And so we do 3, because we already did 2 plus 1, times 3, which would yield 9, and we're done traversing through the array. This was the last index or element, and so we simply output a final value of 9. Right? And so in example 2 and 3, applying that same logic, we would output 6 and 22 respectively. We just have longer lengths inputs and a little bit more operations and operands as well. Okay, and feel free to pause the video and go through the examples yourself to actually evaluate and understand how they actually got to that final answer. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so to kind of just explain the structure and the algorithm that we're going to be using to actually solve this problem efficiently, we're actually going to be using a stack to solve this problem. And the reason why is because of its LIFO, or last in, first out property. In RPN, or reverse Polish notation, operands, or basically digits, appear before the operator. And so when we actually encounter an operator, we need to apply it to the most recent operands using the stack's LIFO property that allows us to easily retrieve the last two operands when we encounter an operator, making it ideal to apply that operator on those most two elements, making it ideal for this situation. Right? And for efficient operand management, we'll push numbers or operands onto the stack as we encounter them in the list. And when we actually find an operator in any traversal or index of the input, we'll pop the last two numbers of the stack and then apply the operation on those two elements and push the result or resulting value back onto the stack. And this keeps the evaluation process efficient and straightforward. So when handling operations, for example, if we encounter the operator plus, for say, we can pop the top two values from the stack, perform the addition on those two elements, and push the result back to our stack. And the same logic, of course, applies for subtraction, multiplication, and division. So how it works step by step is we're essentially going to initialize an empty stack. We'll traverse the tokens. If the token is an operand or a number, we'll push it onto the stack. If the token is an operator, then we'll pop the most recent two elements from the stack and apply the operator and push that result back. And at the end, the stack is going to have one element, which will eventually be or store the result of our expression. So the way we're going to do this is we're going to initialize that stack. I'm literally just going to call it stack, because why not? That isn't a keyword in Python. And I'm going to initialize it to be an empty stack, as denoted by these brackets in Python. Then I'm going to traverse through, or iterate through, all the different strings in my input array, tokens. So I'll do that using a for loop here, a standard for loop, not a range of the length of the indices of the for loop. So I'll say for I as my iterator in the tokens input, I have to have basically a series of conditionals to check if I'm looking at an operator or not. So first I'm going to say if I, or the current element that I'm looking at in this iteration, if that's actually equal to the string of a plus sign, and the reason why we do a string is because these elements are all inputted as strings within the array. So if this is a plus sign, we know to append to our stack, as we talked about before, the sum of the most recent elements. So that's just going to be stack.pop, stack.pop. We're essentially popping the most two recent elements from the stack and adding the result of those two values into our stack as a new value using that operator when we actually encounter that plus operator. That's why we add them, because it's a plus operator. We'll have another conditional that's going to be if the current element I, if that's actually equal to a multiplication symbol, we know we can stack.append literally the same thing. In fact, I'm just going to copy and paste this line and replace the plus with a multiply. Same thing except multiply, right? Because of course I'm looking at a multiplication operator. And the reason why addition and multiplication are a lot more easier to handle is because the order doesn't necessarily matter for these two operations as it's defined to be in the problem. Right? We simply have to multiply or add based on these operator values or status the top most recent elements in our stack as we traverse through it, right? Which is very, very simple, right? The order doesn't matter. For example, if I had 5 times 3, that's equal to 3 times 5, and the same thing for 5 plus 3, which is equal to 3 plus 5. But of course, in division and subtraction, 5 minus 3 is of course not equal to 3 minus 5, and of course 5 divided by 3 is of course not equal to 3 divided by 5. And so that's going to be a little bit more complex to actually handle when we actually reach division or subtraction operators, because the order does matter. So we'll have another conditional if the current element I, if that's actually equal to a string of a subtraction, then we know we can't just directly add to our stack.pop minus stack.pop, because if you actually read the reverse Polish notation formula or rules standard as such, we want to actually pop the second most recent element and subtract the most recent element from that value. So instead of doing stack.pop minus stack.pop, we're actually going to store the second most recent element and the first most recent element and subtract the first most recent element from the second most recent element instead of just subtracting the second most recent element from the first most recent element. So to better visualize that, I'm literally just going to say first and second to be the stack.pop. Oops. And stack.pop are the most two recent elements, again, in these first and second variables. And I'm actually going to stack.append rather than first minus second. I'll do second minus first, because that's how it's defined to be in the reverse Polish notation. We want to do the first most recent element and subtract that from the second most recent element when we actually encounter a subtraction operator. And now really we can just copy and paste this for division as well, when our operator is actually going to be a division sign, and we'll just go like this. But there is another issue. First of all, we actually have a big constraint that our division between two integers always has to truncate towards 0. In this case, when we just simply use, or let me just change this real quick, when we just simply use this division operator, this won't actually work. And the major reason why that is because when we use this division operator in really any main programming language, that automatically rounds down to 0. So when we have positive integers, that's fine, right? It's going to round down or close to 0. However, when we don't actually have positive integers, let's say we have negative integers like negative 11 and negative 7, that would still round down. That would not round up to 0 because we have negative integers. That would still round down. And so that's actually not going to be allowed. Okay? We actually have to round close to 0. And so if we actually have negative numbers, that should not matter. We should still round up in that case to 0. So I will give you guys a few seconds to kind of just think through that problem in your head and try to think how you'd actually handle that case. And then I'll show you guys how I would efficiently solve that. And in Python, it's even easier than you think. Okay, so essentially the way we do this is, instead of simply just doing second divided by first, as you can see, that would actually just divide close to zero. So even divide close to, or down to zero. So even if we had negative numbers, it would still round down, which of course is not closer to zero, right? That only applies to positive integers. And the way we actually truncate towards zero in division is we literally just use the integer keyword, right? We'll literally just say int and convert this operator or operation into an int, which is actually very nice because it automatically truncates its division value to zero, right? That's something kind of local to Python, but it's really cool. And if you guys are not non-Python users, elif is the same thing as else if in Java and C++. We don't literally have to type else if. It's just one word and concatenated into just one word of elif, right? I think that's cool. Doesn't really matter. It's really the same thing. And then finally, we're going to have a final else statement. And if we actually go into our else statement, that tells us that we aren't looking at an operator in this current iteration or traversal of our input string array tokens, right? We're looking at an operand or a number, and so we can simply add to our stack the regular number of itself, but since they're actually inputted as strings, we want to actually add the integer of that number, so integer of I, because we don't want to add a string of i's, because that would not allow us to actually use that to operate and divide, multiply, subtract, or add, because we can't add or do the rest of the operations with strings. We can only do that with integers, and so we actually have to add the integer value of I in this traversal to our stack, because of course a string would not actually be applicable, as we can't actually do multiplication or any of these operators with strings. We can only do them with integers. So once we actually convert it to an integer or int I, then we can add it to the stack. And ultimately, the final thing we have to do after we actually exit this for loop is return the stack at 0. Okay? And unless I made any syntax errors here, this should actually be accepted, and this should be submitted. And as you can see, this is just about as efficient as you can get, right? And you still may be a little bit confused on why we actually return stack at 0, right? Why do we return the very first or 0th element of the stack? And the reason why is, at the end of the traversal, we'll basically return stack at 0, because after processing all of the tokens, both operands and operators, the stack will contain exactly one element, which ultimately will store or represent the final result of the evaluated expression. And that's really because each operator consumes 2 operands and pushes a single result back onto the stack. And so by the time we've processed all the tokens, only the final result, or basically one value, is going to remain in the stack, which is going to be the 0th element of the stack. And the way that reverse Polish notation actually works is that it ensures that after every operation, the stack size decreases by 1, because we pop 2 operands and push the result, and by the time all operations are performed, the stack will shrink to a single element, which is going to be the correct answer. And so returning stack at 0 retrieves or outputs this final result, which of course is what the problem asks you to do, right? So if you guys enjoyed this video and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.